Good afternoon, everybody. Welcome to exciting afternoon and exciting summer of organic chemistry with me, Dr. White, your host. Welcome. Thank you for registering for my course. Now, a couple important things. First of all, I'll tell you this semester, you'll learn a lot about me personally. It comes out when I teach. This slips out. But the first important thing, if we were face to face, I'd be telling you this is my hearing is not that good because I'm at home on Zoom up here above my monitor and webcam. I have two huge amplified speakers cranked up. Yes, they're on. Once in a while, I have to turn them on. Somebody says something, what did you say? And I can hear, oh, turn on. But anyways, my hearing is not the best. It's hereditary. I inherited it from my mother, who inherited it from my grandfather. And if we were face to face, I'd have my hearing aids in, but because I have amplified speakers, I can get away with that. But still, what it means is if you talk softly, or if you talk with an accent, or if you talk softly with an accent, I might have a hard time understanding what you said. That happens face to face too. That's my problem. If I ask you to repeat something once or twice, please be patient with me. Again, that's my hearing. Now, the most important things I'm going to teach you today is the following. Please listen. In my class, in my universe, there's no such thing as a dumb question. I'll say that again. In my class, in my universe, anywhere in my life, there's no such thing as a dumb question. I learned that lesson from Dr. Larry Plavin. I haven't seen Larry in decades. If you notice, I'm a little older than most of you. Well, that was an understatement. But anyways, when I was in grad school, I got my PhD in organic chemistry. Yes, I'm a synthetic organic chemist from Michigan State. And the research group I belong to on Friday mornings, we have research meetings. And part of the meeting each week, a couple people get up and talk about their research. What are they doing? What problems and all that? And I was talking about my research. And hold on. And I'd put up something on the board. And Dr. Plavin, he was a postdoctoral fellow. Postdoctoral fellow is someone who has a PhD but doesn't have a full-time job yet, either in academics or industry. So you go work for another professor at a nice salary until you get a real job. And he was it's called postdocing in our group. And he asked me a question. Could you show me the mechanism of this reaction? And I did, because that was my key reaction I was using in my research. And afterward, I went to Larry and said, weren't you embarrassed asking that question? We teach that mechanism to undergrad organic chemistry majors. He said, why should I be embarrassed? I didn't know it. Now I do. What's wrong with that? And I didn't come up with the phrase, but I realized never be afraid to ask a question. And years later, I don't know when, I came up with the phrase myself. There's no such thing as a dumb question. And I practiced that. So always, always feel free to ask questions in my class. In Zoom, you can either turn on your microphone or you can use the chat at the bottom down here somewhere around here on my screen. I don't know where it is on yours. All right. Now, one of the things I'll be using is this whiteboard. And let me switch over to it. And there's everybody see a blank white screen? Raise your thumb. Give me a thumbs up. Thank you. Zoom has a thing where you think it's on, you're sharing and you're not. And I've tried contacting them with an idea how to change it. They haven't gotten back to me. If anybody knows anybody at Zoom, let me know. But, oh, I got to turn it on. Hello. Wait a second. All right, let me get rid of this. All right, now I'll be writing on the board like this. Have you see, I've gotten it down. I've been doing this now for over a year and a half now. By the way, this is propane. Don't write this down, but propane is CH3. C is carbon, 3 hydrogens, another carbon with 2 hydrogens, and another carbon with 3 hydrogens. Propane, that's the stuff in the white tank for your barbecue. Don't write this down. I'm doing an experiment with your brain this morning or this afternoon. But anyways, I'll be using this. If you can't read anything on there that I write, and sometimes my writing isn't the best, you can always feel free to ask, what the heck is that? What'd you write there? So always feel free to ask questions. Now, while I have this up here, if last time I looked, I don't walk in water unless it's frozen. Even then I stay off it, which in other words, I'm not perfect. So if ever I do on something like this, I hope you all raise your hand or say, that's wrong. 2 + 2 is not 7. By the way, I write my 7 the European way. In high school, I had a German teacher from Germany, Herr Brink, great teacher. I still remember him. And he used to write his 7s the German way with a line like that. And I thought that was the coolest thing in the world. And I've been doing it ever since. Because it is the coolest thing in the world for me. So if I ever make a mistake, tell me. Because guess what? I'm not perfect. By the way, I have this here, propane, CH3, CH2, CH3. Again, it's the gas you burn for your barbecue. Now, I already mentioned about, would you please keep your microphone off? I have it set off. This way it keeps the background noise, which when I first did Zoom, I didn't do that. And within 5 minutes, I realized this is a big mistake. Less than it's all the noise that was drowning out me talking. Not on purpose, but just happened. Please don't share the password with anybody. When we started out in Zoom, I didn't have a password set. I got Zoom Bob. Luckily, I knew everybody's name, so I got rid of them in the next class. And ever since, I've been using a password. Couple things. If what I will be doing is, if you come on Monday, Tuesday, Wednesday, and Thursday, I will be doing just like if we were face-to-face teaching in the summer at ECC. I've taught Chem 170 and also its equivalent Chem 1211 or 1212, I'm sorry, at COD a number of times this summer. And the first time I was going to teach organic in the summer, I figured, oh my goodness, it's only 8 weeks instead of 16. I wonder how good the class will be. And I was surprised, and I've always been surprised. Summer classes usually do much better than the fall and spring classes. I don't know if it's because you're only class or what, but you do much better. But because we're going much faster, keep up, don't fall behind. I'll talk more about that. Now, I don't know how many of you are not familiar with ECC and its LIM system, educational platform system or learning platform system. And let me just show you it. Don't want that. All right, everybody see ECC on your screen right now? And this is the main website, elgin.edu. And if you go to that, you'll see under resources over in the upper right, if you click on that, it has D2L. D2L stands for desire to learn, and everybody just calls it D2L, its acronym. If you click on this, everybody see the welcome screen on D2L? Thank you. And let me log in. I've already logged in, so I can just click on this. And this is my login page. And if you notice, you have this weird thing here right here. By the way, this is a picture, a close-up picture of a condenser. I'll teach you later on the semester what is a condenser. This is a picture of the style of my favorite condenser when I did research for my PhD, which is why I put it here. And if I click on Chem 170, you'll see my welcome here. Hopefully you've read that. I sent out an email. I also have a YouTube welcome that you can watch at your leisure. Important information here are the Zoom. If you click on this right here, this is a link to our Zoom meetings. If you ever forget, it's also in my syllabus. We'll go over that. And then I use a different link for my office hours, which is at night on Zoom from 6 to 7:15 on Monday and Wednesday. In the summer, faculty are not required to have office hours, but I think it's a good thing to have them because that will help you, which is what I'm trying to do when I'm teaching, help students learn organic chemistry. Here's my email address, and I'll do this, and here's a link to my syllabus. Now, if you look at the very top, you have content, assignments, grades, and those are the key ones for you. If I click on content, you'll see I have right here my syllabus, then login information again, my YouTube, and here are my lectures. Now, every lecture I will give, I have both as a Word document and a PDF file, the slides I will be using. I should mention, for many decades, I was a senior research and development manager for a couple different chemical companies. I've done more PowerPoint presentations than I can ever remember. I had $1 for every one. I could probably retire and go to Europe on a nice vacation. But for teaching, it's better for you, for me to use Word. Also, being someone who's given a lot of presentations now, taught for a long time, the less cluttered a slide is, the better it is, easier it is to understand. And mine, I don't have all these fancy stuff on it, which you can do in PowerPoint, and I know how to do. It has the information you need to learn the material. Speaking about material, let's do a quick slide change. Propane is CH3, CH2, CH3. Propane, you know, this stuff in the white tank for your barbecue. Over the next 20, 30 minutes, I'm going to try and get the Guinness Book of World Record for saying propane and structure the most times. Now, during the semester, I don't have any here, I'll have different assignments for you to do. And those assignments for this class are laboratories and tests and the final. And I'll post it here for you to download, and you'll upload it as either a Word document or a PDF file. And I have files, how to do PDF files. If you don't have a scanner, if you have a smartphone. By the way, has anybody ever seen a dumb phone? I haven't. But anyways, how to make a PDF file if you don't have a scanner. It's real simple. And you'll be uploading this. And I'll talk more about this when the first lab and the first test is. And this is everybody's. You'll see in D2L, you'll have your grades, which I'll post. Again, this is D2L. And one thing I should warn you about is at COD, which I'm teaching a class this summer, their system is called Blackboard. And once in a while, I'll say to you, don't forget, this is in Blackboard. And you say, what? No, I should have said D2L. And I do the same thing over there. I say D2L when I should have said Blackboard. So if you're ever confused, ask. Remember, there's no such thing as a dumb question. Now, if you go to D2L, let's go through my syllabus. I'm not going to go through all of it. I'm assuming you could read it on your own. There are parts of it I'm required, not only me, but all faculty put in. You can skip. But there are important things I'd like to talk about in the syllabus. So let's take a look. Everybody see the course syllabus on top? Thumbs up, people. And a couple things. I'm Dr. White, and here's an office phone, which is really a voicemail box. And honestly, I can't remember the last decade I checked this, or last, I think it's about 10 years ago I checked. I don't even remember the password. The best way to reach me is by email, kwhite@elgin.edu. This is in the syllabus, which you can download. I check the email twice a day. Now, listen carefully. I'm an early riser. I have been since I was about 7 or earlier, maybe. Usually I start working by 5:30 a.m. So usually I check my email by 6 a.m. and later after class, 5, 6, 7, or 8 p.m., I'll check it. Then I also check it on Saturday and Sunday, sometimes more frequently, but at least twice, once in the morning, very early, one later afternoon or evening. All right, in the syllabus, we have the link for the Zoom meeting. Also, if you want to call in, here's the mobile phone number. And here's my YouTube channel. I should point out, if you go there, let's go there. Hold on one sec. Yeah, you can go on your own. You'll see last semester's Chem 170 is there. It's a 16-week, but I'll be doing each lecture here on Zoom. And I'll post the Zoom lectures in YouTube. Here's the office hour link, which is different from the lecture. And like I said, the easiest way to find me is email. Now, if you go on, look at things I send out via D2L, I think it has K White at something different here. I forgot what it is, but anyways, use this one, kwhite@elgin.edu. Make sure that's the one you use, because the other one doesn't get to me. I thought I'd have it rerouted, but most of the time it still doesn't work. This is stuff you don't have to look at. All right, lab book, I'll be giving out labs in the assignment area for you to download. And when I inherited this class a long time ago, the labs were awful. And being an organic chemist, I challenged myself and I rewrote all the labs myself. Part of the problem was normal labs in a lab book for this type of chemistry, which we teach at COD, I have many times, is almost a 3-hour lab. At ECC, when we're face to face, I have 1 hour and 50 minutes, which is why I rewrote them. Now, I've made the book optional, which really means don't buy the book. One, they don't give me any kickbacks for selling books. And two, a number of years ago, that's a decent book. There's a copy right over there. But what I talk about most is followed in the book. I add a lot more because I worked in the real world in the chemical industry. For some reason, about 2/3 during the semester when we were face-to-face at ECC, I just I don't know what made me do it. I asked students, how many of you are reading the book and keeping up with me in the book? Nobody raised their hand. And at first I was upset. So I looked at the scores of the last test, which were quite good. I figured if you're doing well in learning organic chemistry without the book, and they're not giving me any money to sell it, don't buy the book. And by the way, you can go to ratemyprofessor.com. You'll see students who have taken Chem 170 say the same thing. Ooh, I've been amiss. Propane, it's still CH3, CH2, CH3. Propane, it's the stuff in the white tanks for your barbecue. Bet you didn't realize when you were cooking on your barbecue, you were doing organic chemistry. Here's a course description. I'll let you read that. Attendance is recommended. Thank you all for showing up today. I think I have 18 registered. Half of you showed up, and some of you might be working now, and I understand that. But I will be posting the lectures on Zoom. When it comes to behavior, the main thing is please don't cheat on tests. I have ways of putting things in tests, even when I do it online, to find out if the student's cheating. And I'm a pretty laid back person. There's only two things that get me upset, and you don't want to see me upset. I don't want to see me upset. That's people who lie to me and students who cheat. Cheat is just a form of lying in my mind, or students say, I know this, and they really didn't. But students do very well in my class, and I'll talk more about that. And I'd ask you to read this about unacceptable behavior. I've never had a problem here. I had one time at COD, the student had serious psychological problems, and found out Dr. White's been a senior manager, and I know how to deal with people. But anyways, I'll let you read that on your own. In Zoom, we have anybody. I'd ask you, try and, you don't have to buy the book. Try and look at, well, you don't have to look at it, but I strongly recommend you do the practice problems. I'll talk more about this. Now, do not raise your hand or any way let anybody know about this, but see me in private. If you're a special needs student, I've been working with special needs students for many years, and I work with the program at ECC and also at COD for many years, and I strongly support it. If you need any special needs and you have authorization from the Learning Center, let me know, and I will help you in any way I can. One of the nice things about this semester that helps special needs students, I've had last semester and the previous, all my lectures are on YouTube, so you can go back and watch things. All right, now, in case you haven't learned, Dr. White was a student just like you in a galaxy far, far away a long time ago. A long time ago. By the way, I got my undergraduate degree from Illinois Institute of Technology. As I mentioned earlier, I got my PhD in synthetic organic chemistry from Michigan State, which means I've been a student for a long time when I was. And I should mention, I teach by my golden rule of teaching. Ooh, what's that? I don't do to my students what I didn't like done to me. So right now, what's probably the most important thing? Well, how do I get a good grade in this class? And let's talk about that. There's going to be 4 tests, and they're 1-hour tests, and here's the dates. You'll be given extensive time, so you have time to hand it in, upload it. And these are tentative. Once in a while, I may change it by a day or so if I feel it would help the class. But that's rare in the summer. All right. There'll be a 2-hour comprehensive exam on the last day of class at 1 p.m. I'll have extra credit during the semester, 1 extra credit project. And in terms of makeup, unless there's some extreme emergency, please get the test in on time to me. You'll be uploading it, you'll take it at home. Now, when it comes to your final grade, and this is the syllabus, what I do is take the 3 highest test scores of your 4 tests. Each test 100 points, that's 300 points. The final exam, 200. Relax, students do good on my final, and you'll learn. And then we'll have, I think it's 14 or 13 lab reports. Each one are 11 points, which is 132 points. I drop one of the labs too. Add it up, and that adds up to 630, or say actually 632. It's a typo error here. I'll have to change. I got it right down here. See, I told you I'm not perfect. And what I do is calculate a percentage. Let me blow this up a little. Everybody see this percentage all right? Thank you. And it's the sum of the 3 highest test points, your final exam, your lab total, and your extra credit. If you do an extra credit project, it's optional, times 100 divided by 632, you get a percentage. If you're 90 and above, you get an A, 80 to 89, B, C, 70 to 79, D, 60 to 69, and F, 59 or less. Now, when I do it face-to-face, and here I'm being sort of selfish, and I can be at times, I expect, and I usually do, when I'm face-to-face, usually about 70% of the class, and the important word is earn an A. Yes, that good. And the rest do pretty good too. Now, since I've switched to D2L, to Zoom, and I think part of it is I've been told feedback from students where they can go back and rewatch lectures. It's gone up even a little higher. Students do well if you follow what I'll teach you, how to do well in organic chemistry. And you got to put in the time, but if you do, you'll do well. Speaking about doing well, time out for a break. Propane, CH3, CH2, CH3, propane. I said I'd do it a lot of times, and I'm not lying. So that's how you get the final grade. It's not subjective, it's based on points. And withdrawal policy over the years, the only reason students have withdrawn is one, due to pregnancy, and the other, if they get transferred outside the Chicagoland area. This is when we were face-to-face. And incompletes, here's my policy. If you need an incomplete, I'll support you. I'm here to help you, not to make your life difficult. Here's the tentative schedule. Remember, in the summer, each week in the summer is the same as 2 weeks in the fall or spring. And here's the tentative schedule. Notice I have the different things that are important in red, the test 1, 2. Notice on the 5th, will be off because there'll be no class because the 4th is long weekend, and so on. And then I have a section which I'll cover on Wednesday about labs. I also have the lab schedule here. Actually, I guess I'm going to do this. Now that I think about it, I better do this today. The lab check-in, we don't have a safety video because we're not going to be in the lab, so I don't have to do that. And I'll talk a little about the lab later today. Now, at the very end, I have what's called the student agreement. And I do this face-to-face too, but I modified it for Zoom. Now, if you go to the syllabus section of the contents, you'll find this agreement. Let me open up the actual one. Everybody see I print your name on the screen? This is the one you can download from there. I'll also put it later in the day in the assignment area so you can upload it. And essentially it says you've read my syllabus, understand it's your responsibility to abide by these principles or policies, and you understand failure to abide by the policies will result in the consequences outlined in the syllabus. Now, since I'm posting our lectures on YouTube, and when I have it like this, some of you can see your face on the screen. If I minimize it, you don't. Because of FERPA, which is, I think that's the right acronym, which is part of the federal government law dealing with privacy of students, I also have this. I understand that the instructor of this course will be videotaping all Zoom meetings for this course, and the instructor of this course will be posting these videos of those meetings on YouTube for public viewing. Therefore, I waive your FERPA. I was right on the acronym. Rights concerning your name, image, or voice appearing in these. And here you sign it and date it. As per my syllabus, if you don't have this to me by test number 1, you can't take test number 1, you'll get a 0. In other words, please get it to me as soon as possible. And one more time, propane. It's still CH3, CH2, CH3, propane. That's an organic chemical. But you didn't think when you were doing your barbecue or replacing a tank, that's organic chemistry. All right, any questions so far? I'll look at chat. Remember, there's no such thing as a dumb question. Now, one of the things, if you notice, is today goes from 1 until 3:50. When I do face-to-face, and I've learned Zoom is no different, when you're sitting for more than 50 minutes, your brain shuts down. I learned that as a student, and I learned that as a teacher. Therefore, we will be taking breaks. Normally, when it's face-to-face, I give you a 10-minute break. But for Zoom, I've found it works quite well. If we take a 5-minute break, it allows me to get up and stretch a little and maybe refill my water bottle or whatever, you get up, whatever. And because of that, even though it says 3:50, we'll get out, since I'm doing 2 of the breaks are shorter, I'll let you out 10 minutes early. One of the things I hated when I was a student was, have you ever had one of those instructors that keeps on going on and on and on, and it's past the end of the class? Come on, I got to get somewhere. Well, remember, I don't do it with my students. Do to my students what I didn't like done to me. I always end on time within a minute or so of the end of it, whenever I'm going to say I'm going to stop. By the way, I have my little notes here for today's this part of the lecture. All right, quick question. And how many of you know about the emojis and Zoom, which I have renamed Symboli? Anyways, I should warn you, I use humor in my class. Sometimes it's good humor days I have. Sometimes, well, you just got to suffer along with me with my bad humor. That's just part of it. I need to warn you about that. How many of you read about me at ratemyprofessor.com? Anybody give me a thumbs up or your thumbs up? Well, you'll find out if they're telling the truth or not. They are. But anyways, let me ask you this. With, I should actually, let's see if I can do one real quick. That's not what I want. And I don't have it set up right now, but use the thumbs up thing and let me go to a different view. How many of you are here because you have an undying love for organic chemistry? How many of you are here because you're going to be an organic chemist? Give me a thumbs up. How many of you are here because someone said you had to take organic chemistry to get into school or program? Give me a thumbs up. See, I already knew that, but now you know I know that. I am not going to try and convince you or turn you into organic chemists, even though it is fun. Yes, it is fun, but I'm biased. I'm a synthetic organic chemist. By the word synthetic or synthesis means to make, and my training has been to make molecules. And that's also why I have 10 US patents, because I've done it quite well. Anyways, I know that, now you know that, and part of my job is to help you get the best grade in my course you're willing to work for. I'll say that again, my job is to help you get the best grade in my class you're willing to work for. The key thing is to work for it. Now, how do you do that? But first, a commercial from Dr. White. Propane is still CH3, CH2, CH3, propane. All right, how do you learn organic chemistry? How many of you heard organic chemistry is really hard and tough? You know, one person has usually, and some others are afraid to say that. But organic chemistry, go talk to any doctor or nurse. Most of them hate organic chemistry. But anyways, organic chemistry is fun, but I'm biased. How do you learn organic chemistry? Well, let's talk about bicycles. Bicycles. Let me change view. Bicycles, yeah. Let's assume you've never been on a bicycle and you don't know how to ride a bicycle. And me being the nice person I am, which I am, I give you the best Blu-ray disc ever made on how to ride a bicycle. And you have one of those monster big screen high def TVs and a nice Blu-ray player. You put it in there, and for the next month, you watch that. Slow motion, back and forth. So you know almost every frame on there by heart. What's going to happen the first time you get on a bicycle? You're going to fall off. You need to practice. This course is no different. In fact, anything you master learn is no different. I have provided practice problems. The ones in the book are awful in most books there are. And years ago, I said, how do I make my students perform better on the test? Practice. And I wrote my own practice problems, and those are in D2L. Also the answers. And you'll see me during the semester doing practice problems, and you'll say, oh, it doesn't look that hard. It's just like watching the Blu-ray on how to ride a bicycle. Question is, where do you want to fall off? On the practice problems or on the test? I hope you all said practice problems. And that's why my students do quite well. Because when they take the test, by the way, when you see the first test, you'll understand. Hint, hint, wink, wink, say no more. By the way, I stole that from Monty Python. If you don't know about Monty Python, the Flying Circus, check YouTube. But anyways, I think everything's on YouTube except my PhD graduation, my high school and college graduation. Everything else I think is there. But anyways, when you see the first test, you'll understand why I call them practice problems. And now, once again, propane, CH3, CH2, CH3, propane. Now, one of the things I found a number of years ago, and maybe next Monday after class, anybody wants to stick around, this is one thing I will cut out of the video. And if you can't make it to class, come to my office hour. Years ago, based on somebody else's work, I created, I call it the method. It's a way of eliminating test anxiety, which for some students is a bad problem. You know the material, you on the practice problems, you do it correctly, you sit down for a test and your mind goes, and you don't know what's going on, you do bad. Well, I found a way to eliminate test anxiety. It takes about 10, 15 minutes for me to teach to people, and it works. I've had students going from low C, D, or F to B or A students, not only in my class, but it works for other ones, and I'll teach that. Another thing I'll do later in the semester, which I'll cut out of the video, I like that, special effects, cut out of the video. So I have bad humor days. But anyways, as someone who's been a senior R&D manager in the different international chemical companies, A, I know how to interview for six-figure jobs, and B, I've had to hire people, so I know about what's a good interview. And later in the semester, I'll take some time at the end of class. I'll give you some really good pointers how to interview that helps students, A, get jobs, and they have, and I'll tell some stories how effective it's been, and B, get into places like nursing school where you have to go for an interview like UIC. And propane, it's CH3, CH2, CH3, propane. It's an organic molecule. Just looking at my notes. All right. Well, I've already established, and I was looking at the clock for break is coming up soon, but I've already established you're not going to be organic chemists. But you're here because somebody said you had to take this class. Why learn organic chemistry? Well, let's think about this. You look at my shirt, that's made of molecules, cotton and other things. They're organic molecules. By the way, don't get confused with the advertising term organic, like an organic food, because all food is organic molecules. So technically all food is organic, but it's been stolen, that word, for another meaning too. But let's think about it. My clothes is organic. My food is organic. You had to have something for lunch, like, I don't know, hot dog, hamburger, French fry, all the things I shouldn't have. But anyways, that's all organic molecules. All right. Hopefully this won't hurt. Everybody, touch your skin. Go ahead. It won't, hopefully it won't hurt. Go ahead. Trust me, I'm a doctor. That work? Touch it. Your skin is organic molecules. That's organic chemistry. When you eat food and it goes in your stomach and you break it down, digest it, you're doing organic chemical reactions. My hair and beard, what's left of it, those are organic molecules. So let's see, why should you, oh, hold on. See this bottle here? I'll teach you about that. That's organic molecules. That's organic chemistry. So let's think about it. My skin is organic chemistry. My clothes is, my food is. Just about everything around me is organic. The plastic of that frame, my favorite picture from the movie Forbidden Planet is, by the way, I have a list of my favorite stuff on D2L in case you want to look at good books, movies, or music. But anyways, that's organic. So isn't it obvious why you should be learning organic chemistry? Of course it is, because somebody told you you have to take this and you want a good grade. And I know that, and I'm going to help you do that. All right, everybody see propane, CH3, CH2, CH3 on the screen? All right, everybody, and hopefully you're in a safe place and you're not driving. If you're driving, don't do this. I actually had it one class 2 semesters ago. One student would be driving downtown, listen to me on their car, on their phone in their car during my lectures, then watch it on YouTube. Anyways, if you're not driving a car or truck or anything like that, or using heavy equipment, close your eyes right now. How many of you can picture the structure of propane? I think most of you can open your eyes now. What I did was I did an experiment. I don't know how I came about this, but in organic chemistry, I'm not going to sugarcoat it, there's a lot of memorization, a lot. And the best way to learn it is write it down and say it 5 times, twice, or 3 times, depends on the person. And what I just did in the last 35 minutes was an obnoxious number of times, propane, CH3, CH2, CH3. If you write it down 5 times and say it, you'll remember it. Now, years ago, after a first test in Chem 170, I had 2 friends. One did real good, aced it. The other one, really bad. And they both came up to me after class, and the one who did real bad said, how can I do better in class? And I said, have you done the practice problems? Sort of. Have you been writing things down and saying it 5 times? She said, no, that's a lot of work. And her friend said to me, yeah, that's a lot of work, but I got an A on the test. And the first student who didn't do good got the message, and she brought her grade up real well by doing that. You got to put the time in. All right. One thing I haven't talked about, I should mention, is the math requirement for this class. And it's quite brutal. For about through week 6, you have to know how to add and subtract up to 4. You can't use any electronic devices. You also have to know how to count up to 10. And I'm going to make it real hard. From the numbers 1 through 10, you have to know which ones are bigger and smaller than the other ones. You have to know 9 is bigger than 7, 3 is smaller than 5. Now, I think it's about week 6 or 7, you have to know how to count up to 18. And that's all the math you have to do for my class. So hopefully you know how to count up to 4 and add and subtract, and up to 4 and count up to 10. And that's that. Any questions? Going once, twice. I don't have it. The way I'll do it is, you have a question, Matt?
Yeah.
Just turn on your microphone.
Okay, I just had a question about the tests. You said the finals, the 2 hours at 1 o'clock. How are the first 4 time that they're going to be done?
Couple of things. First of all, the way I do the test in here is, technically I say it starts at 1, but you'll have until 10 the next morning to finish it and upload it. I go on the honor system because under COVID-19, stuff happens. I've had students, I've had some students who work in nursing homes, pharmacies, or EMTs at hospitals. They've had to work extra shifts because their colleagues have come down with the virus or test positive. That happens, and I trust my students. Also, I put secret things in there to know if you're cheating, so please don't. But that way, the other thing is, when I do give it face to face, you have 2 hours. Most of the students I've taught Chem 170 once, twice, a lot of times at ECC, are usually done in about an hour and 20 minutes. The average score is quite good, and I'll talk about that later on. So that's one of those, take a deep breath, let it out. Students do good on the final. Also, if you look at the syllabus, we'll spend during the last week a couple hours where I'll do a review of the whole semester, which I also do in fall and spring, but in summer, and it helps students do good on the final. Does that help? And does that answer your question?
Yes, very much. I was just curious with my work schedule, just what days. So where that works perfect. Thank you so much.
You're welcome. By the way, I haven't said it, and I'll be mentioning it off and on next couple of days. Truly, there's no such thing as a dumb question. If I look at the clock, oh no, I've gone a minute over. Let's take a 5-minute break. I can go stretch. I'm a little older than you guys, so I need to stretch so I don't cramp up from sitting like this. I'll see you in 5 minutes. Let's see. Let's call 1:56, and I'll be back. And you too. All right, let's get back to work. I found this gets everybody back to work. By the way, I should warn you, in front of a camera on Zoom, Dr. White can be a wild and crazy guy. By the way, for those of you who know about SNL, Saturday Night Live, way back when it was real good, it started better, but it's not like originally. Steve Martin, Dan Aykroyd had this skit, long-running skit, different episodes where they were two wild and crazy guys, which I just stole from them. Someday I'll have to tell you the story about Animal House. How many of you seen the movie Animal House? It was written about the fraternity I was in, actual chapter, but that's a story for another day. All right, let's begin our venture into organic chemistry. One of the things you'll learn this semester is my world of organic chemistry is your world of organic chemistry. You just don't know about it yet. By the end of the semester, you will. And that allows me also to get into some really neat things. You would say, he's going to talk about that. And the answer is, yeah, it's organic chemistry. And part of the reason I can do that is for many decades before I started teaching, I was a senior research and development manager in the chemical industry. And part of my job was also do problem solving at plants of our company and also customer problems. And I'll talk about that during the semester. If I butcher your name, Johanna, remind me, how many items a week, a couple days before each test, I'll put out an email and discuss it in class, how many problems, what area it's already in the syllabus, what parts are going to be covered. I write my test the way, remember my golden rule, and that is, even though usually I was one of the top students in science class and math, by the way, I was always the first one down in the spelling bee. Thank God for spell check. But anyways, I shouldn't bring religion into the classroom. But my tests are written. So one, if I am face to face, if we were having, normally they're 50 minutes, most students are done in about 35, 40 minutes. And if you've done the practice problems, students do well on my test. It's as simple as that. Hopefully that answers your question. If not, ask it again, but I will give you more information about what's going to be on the test. If I were to tell it now, it doesn't make any sense because I still have to teach you a few things, so it does make sense. But feel free later on to ask it again. All right, let's begin. I'm going to assume all of you at one point had some chemistry. And one other thing, having been a student, I could never read my instructor's mind. Let's do an experiment. How many people can know what I'm thinking about? Were you thinking about methylnonyl ketone as a dog repellent? No, so you can't read my mind. I'll teach you about that later on and a really great story about that. But anyways, since you can't read my mind, I'll discuss more about that during the coming weeks ahead. All right, important thing. I assume you've all had some chemistry. This will never be on test, but does everybody see H on there on the whiteboard? Nope, hold on, let me check. Yep. All right. I'm assuming you don't. If I ever say talking about it, you don't see what I'm talking about, you can open your mic and say, I can't see that. All right. There's certain chemical symbols you should know. H is hydrogen. You should know lithium, potassium, and sodium, because I'll use those. Then calcium and magnesium going across the periodic table. The most important, carbon, and we'll learn about that. Then nitrogen, oxygen, sulfur, the halogens, fluorine, chlorine, bromine, iodine, and a couple of metals, platinum, palladium, and nickel. And these are the elements you should know. I will never ask on a test. By the way, you all have each other as witnesses. I said that. I will never ask on a test what's the chemical symbol for carbon, but I'll use these throughout. So again, H is hydrogen, lithium, Li, K, potassium, Na, sodium, Ca, calcium, I said the Na, so Mg, magnesium, carbon, C, nitrogen, N, oxygen, O, sulfur, S, fluorine, chlorine, chromium, iodine, that's an I. Let me fix it up. That's better. And then the metals, platinum, palladium, and nickel. And as an organic chemist, that's really my periodic table. You could throw in gold and silver if you want to send a donation to the Save Dr. White Foundation, courtesy of the local rock by the train station. But really, that's all the elements you really need for organic chemistry, at least the stuff I do in most of our daily lives. All right, again, I will never ask that. Ooh, I forgot to warn you about something. See that? That's the world's fastest mouse wheel finger, this side and the other side of the Mississippi River. Always feel free to ask, could you go back to the last slide or show me that again? And the answer will always be yes. Because sometimes even face to face, I just start zooming along, getting a certain speed, which is too fast, and slow me down. All right, so in organic chemistry, the main elements from the periodic table: hydrogen, lithium, potassium, sodium, calcium, magnesium, carbon, nitrogen, oxygen, sulfur, fluorine, chlorine, chromium, iodine, and these metals, platinum, palladium, and nickel. And I'll be using those and saying them, and henceforth, I'll assume you know that. Now, organic chemistry is fun. If I say fun enough times, you might believe me. I'm going to be brainwashing your mind. I do experiments, including with your brain. But organic chemistry is broken down into the study of what's called different functional groups. And functional groups are combination. I'll never ask on a test what's a functional group, but I'll use that term a lot. And a functional group is a certain combination of atoms in a molecule. Oh, by the way, I hope you all know what is a molecule: a collection of atoms held together by forces called chemical bonds. And I won't ask that on the test. Things I will ask, you'll know, because Dr. White can be subtle, and I also know you don't know how to read my mind. But anyway, put together in a certain way. And those functional groups always react the same way in chemical reactions and have similar properties. You look over here, you see the door to get into my office in my house. I bet in your house, you have doors that don't look like that. Or if you were to go to ECC and go in the chemistry building, or building M, the door to get in that building is different from that door. But you know the function of a door, how to use it, to go from one area to another. And if it were closed, you'd know to open it. And that's the function of a door. Same thing, I'm sitting on my, you can see my office chair, and you probably are sitting on one that's different. But you know what's the function of a chair. If you were at ECC or face-to-face in a classroom, we'd have different looking chairs in the classroom, but you know what to do with that. Organic chemistry is the same way. And I'll be teaching about different functional groups. There are a couple areas I'll teach you. One, how to name the compounds, which is very important. But the most important part, which is the fun part for me, don't forget, I'm a synthetic organic chemist, is how to make them and how to react them. And because I've worked in the real world, I will also teach you where they're found. Example, next time you wash your hands, the soap, that's organic chemistry. Later in the semester, I'll teach you, way later, how you get your hands clean when you use soap. Do you realize that's organic chemistry? Scary, isn't it? It's all around everywhere. But I'll be teaching you those things. So that's functional group. All right. It's officially time to start your journey into my world of organic chemistry, which is really your world of organic chemistry. All the slides I put up on the screen are in D2L in the lecture section for you to download at your leisure. I have both as a Word file and a PDF. PDF, if you want to look at on your phone, your tablet, or whatever, as opposed to the computer, you can. All right, thumbs up, people. You see chapter 2 on this? Thank you. All right, let's start out with chapter 2 now. And chapter 1 in the book is this talks about little functional groups and what I just talked to you about, the atoms and molecules. All right, when we talk about organic chemistry, the first thing you should know are the hydrocarbons. And what are hydrocarbons? Hydrocarbons are molecules with only carbon and hydrogen atom. And by the way, sometimes I will be subtle. And there are a couple definitions I'd like you to learn. One of them is hydrocarbons. And if you listen to the news, you'll hear about hydrocarbon pollution and things like that. They're talking about molecules with only carbon, hydrogen atoms. So on a test, I could ask, what's a hydrocarbon? 2 points. And the answer is a molecule with only carbon, hydrogen atom. And that's a hydrocarbon. And if I go too fast, I always say, could you please go back? Now, there are 2 types of hydrocarbons. One is a saturated hydrocarbon, and the other is unsaturated hydrocarbon. And hint, you should know this also. See how subtle I am? Now, I don't always write this. Sometimes I'll just say it. But anyways, what is a saturated hydrocarbon? Well, a hydrocarbon is a molecule with only carbon and hydrogen atoms, in which all carbon-carbon bonds are what we call single bonds. A single bond is a sharing of 1 pair of electrons. And hopefully you all know pair means 2. In case you forgot, in an atom, there are 3 subatomic particles, the electron, proton, neutron. And we'll deal mainly with electrons in here. And I'll never ask what's a single bond, but as a student wrote in a ratemyprofessor.com a while ago, so I can't even take credit for this. In my class, they said in Dr. White's class, there's no fill in the blanks because the way he teaches, there are no blanks. But if I ever do leave a blank, don't forget to ask. So single bond is sharing a pair of 1 pair of electrons between atoms, in this case carbon. And a saturated hydrocarbon, you have molecule with only carbon, hydrogen atoms, and all carbon-carbon single bonds. All carbon-carbon bonds are single bonds. And an example of this is propane. And propane is a saturated hydrocarbon. There's only single bonds between each of these carbons. And propane is a saturated hydrocarbon. And I'll teach you about other saturated hydrocarbons. So a saturated hydrocarbon, by the way, if you haven't figured out, Dr. White likes to do repetition because repetition is good for your grade, which makes me happy. Oh, I better tell you something. First of all, I see people writing this down. Everybody got it written down so far? I forgot to warn you. I'm a very selfish person. And the way I'm selfish is very selfish. I like good things to happen around me that make me happy. See how selfish I am? And one of the things that makes me very happy is to see students succeed and get good grades. In fact, one of my greatest wishes is to have a class, listen carefully, where everybody earns an A. I've come close. In fact, a couple of summers ago, I had a class where I had 24 students. I had 22 A's and 2 B's. And first I was very upset. I wish they got an A, until I realized if I hadn't helped them out, they would have flunked. And to go from an F to B is a great accomplishment. And that makes me happy. So make sure you follow what I'm saying and remember things when I say know this. All right, so there are two types of hydrocarbons. Hydrocarbon, molecule with carbon hydrogen atoms. Saturated hydrocarbon has only carbon hydrogen atoms and all carbon-carbon single bonds. Now the other one is unsaturated hydrocarbon. Unsaturated hydrocarbon, well, if it's a hydrocarbon, it's a molecule with only carbon hydrogen atoms. And now what makes it unsaturated, it contains one or more carbon-carbon multiple bonds, which we call double bond and triple bonds. And double bond, in case you forgot, in case I learned how to write, now you should know double bond is two pairs of electrons being shared. Oh, I just thought of something I forgot to ask. Don't raise your hand, but email me or something. I assume everybody can read cursive. If you can't, let me know in private and I'll print, but I sometimes will do both. And also for those who can read cursive, you can't read what I wrote, ask me. By the way, that's being shared. And a triple bond are three pairs of electrons. Being shared. You should see me the first week using my drawing tablet. It was awful. And I practiced that weekend for a number of hours to make it look better. But anyways, an unsaturated hydrocarbon is a molecule with only carbon hydrogen atoms that contain one or more carbon-carbon multiple bonds, which mean double and triple bonds. I'll teach you later on, not this chapter, but the next one. How many of you have ever seen a carrot? Hope all of you have. Dr. White likes carrots, other vegetables too. That's organic chemistry. And the orange color of a carrot, now I didn't bring one up here. I could run down to my refrigerator, but I won't. I think you've all seen it, is due to an unsaturated hydrocarbon. Oh my goodness, that's organic chemistry? Yeah. So next time you see a carrot, the orange color is due to unsaturated hydrocarbons. Now to scare you further, how many of you ever seen a ripe tomato? It's red. And that red color, and I'll teach you the next chapter what actual molecule is doing that, is due to an unsaturated hydrocarbon. Ooh, it's getting scary now. My carrots and tomatoes look the way they do because of organic chemistry? And the answer is yes. How many of you have ever heard the term saturated, unsaturated fats? And I'll teach you later in the semester that saturated fat only has carbon-carbon single bonds, and an unsaturated fat has carbon-carbon double bonds. Now, it turns out, I better explain now, I'll say this more during the semester, you know who's the greatest of all organic chemists? Mother Nature. And I say this with the most sincere respect. She's a great organic chemist. All the stuff around her she's done. But Mother Nature never did a triple bond. That's something organic chemists invented, but she loves double bonds and a lot of other good things too. So let's go back. Saturated hydrocarbon, molecule with only carbon and hydrogen atoms, which all carbon-carbon bonds are single bonds. You should know that. Unsaturated hydrocarbon, molecule with only carbon, hydrogen atoms that contains one or more carbon-carbon, and I can say just double or triple bond. Those are the only two multiple carbon-carbon bonds. It's important to say carbon-carbon. All right, now, I'll never ask you what this is, but I'll use the terminology. Let's talk about the alkanes. Now, alkanes are acyclic saturated hydrocarbons. Ooh, acyclic. One of the benefits of my class this summer is you'll learn a lot of neat words you can impress your friends, neighbors, and loved ones with. And let's look at the term acyclic. Well, cyclic means round like a circle, bicycle, two cycles, two circles. A, the prefix A, and I'll never ask this on a test, but that means without. So an alkane is a saturated hydrocarbon that's straight, not in a circle. And we'll learn more about this. Now, throughout the semester, I'm going to be using the following. Click, just like a light switch, click. Will this be on a test? That switch is in the off position. And for the slide, click, it's in the off position. But still terminology I'll use, and you should know what I'm talking about. So, alkanes have the formula CnH2n plus 2. Do not write this down. The only reason I'm mentioning this is because in certain entrance exams, I've been told, like for nursing, they ask you if you have an alkane with 5 carbons, how many hydrogen? What a stupid question. I'll never put that on a test, but other people don't feel the way I do. And because of the feedback I got, that's why I'm teaching it. Now, it turns out that bonding geometry, atoms, hang on while I get my molecule, atoms and molecules exist in 3 dimensions. And the simplest one I have on here in the center, this is a carbon. Each round right here is a hydrogen. This would be CH4, 1 carbon. And each one of these round balls at the end is a hydrogen. And the geometry, the bond angle here, and this will not be on a test or the final, you got my word on that. By the way, I don't lie to students. I don't lie to anybody. Isn't that nice to know about Dr. White? But anyways, is 109 degrees approximately, and this is called tetrahedra. It's show and tell time. Look, I've got a model. I had, years ago, I had the ECC buy these. They're quite expensive. Set is back then was about $100 a set. And for a class of 24, that's a lot of money. Well, after 2 labs using these, the students said they hated it. I mean, they hated it. So we stopped using that, but I still have the models, and other classes use them. In the center here is a carbon, hydrogen here, 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 here. So 4 hydrogens, carbon. Notice the geometry. This is called tetrahedral. If you put a bunch of them together, it looks like this. It's not really straight, but I'll call this straight. We draw it straight. We don't show the bond angles. So that's an alkane. And what are some examples of alkanes? Well, methane, CH4. This is something you should know. What's methane? You know that as natural gas. And natural gas, the stuff you cook with, if you have a gas oven or gas range or stove, you're burning CH4 methane, natural gas. If you have a hot water heater, which most of us in North Illinois do have, that's flame that burns natural gas, and your furnace, when it gets cold, which it will come November, December, January, and February, you have a heater that burns natural gas methane, and that's an alkane. Now, ethane, how many of you ever seen the little silver cylinders that at a sports event, the trainer, if somebody say sprains their ankle, they spray the stuff on the ankle, all of a sudden this athlete starts walking again. Well, that's ethane. And because it's a gas at room temperature, when it evaporates, it gets real cold on the surface it's coming off of. Now, ethane is also used to ripen certain vegetables. And for, oh, look, how many of you remember this one? It's your old friend propane. And propane is also an alkane, which all the alkanes are also saturated hydrocarbons with only carbon-carbon single bond. Oh, it's getting scary, all the stuff around you that's organic chemistry. Remember, everything you see up here, except when I write this like here, is in D2L. Also, you can ask me to go back and show you something again. And finally, by tomorrow, I would hope by noon, if not earlier, I will have this video from today's lecture posted in YouTube. You didn't know Dr. White's a YouTube star. All right. Now, you can also have what's called cycloalkanes. And cycloalkanes are saturated hydrocarbons. Remember, hydrocarbon, only carbon, hydrogen atoms, and saturated, only carbon-carbon single bonds, which the carbon atoms are connected to one another in a cycle or cyclic arrangement, which we call a ring. Now, this will never be, I'll never ask you on a test, what's a cycloalkane, but we'll talk about them. And I'll never ask on a test because the same thing, some people write standardized tests. You have a cycloalkane with 5 carbons, how many hydrogens? And the answer is 10, but I'll show it to you in case you ever take tests like that. And not all rings are planar, are flat like a piece of paper. And let me show you how you can make a ring. First of all, for those of you, everybody up to speed, it's show and tell time. Here I have a 6-carbon molecule. This would be an alkane. It's not in a ring. Now, if I connect the ends together, I have a ring. We call this, even though it's a hexagon, we call this a ring. This is a 6-membered ring. By the way, Mother Nature and Dr. White loves 6-membered rings. Now you know I'm an organic chemist. That's true. In your hormones, your steroids, there are 3 of these, and a 5-member ring. And I'll teach you about that later in the semester. Yes, your hormones, that's organic chemistry. And the stuff that gives me my beard and also helps you with other things in your body are made up of rings. 3 6-membered and 1 5. This is the cycloalkane. If you notice, this is not flat. There are different conformations, which I don't teach in this class. This is called a boat conformation because it looks like, or a chair conformation. Then it can also flip to the boat. And that won't be on the test. Dr. White's getting carried away, having too much fun. So you have cycloalkanes, which carbons are in a ring. Now, one of the most important things you will have to master, remember, if you have any problems, first always ask questions. There's no such thing as dumb question. If you need extra help, come to my office hours, 6 to 7:15, Monday and Wednesday on Zoom. It's a different login. It's in the syllabus. It's also on the front page of the 170 D2L page. There are different ways of drawing organic chemicals or molecules. One is called the condensed structure, and I'll never ask you on a test what's a condensed structure. And that shows how atoms are connected, but does not show the individual carbon, hydrogen, and sometimes here, usually not the single bonds, but I do show the single bonds. I'll explain why. Another one is called the condensed structure, which with parentheses, same as condensed, but use a pair of parentheses to show a number and a number to show repeating unit of molecule. What the heck is that? Oh, look at the bottom. It says C board, or they should have changed to C whiteboard for examples. So I better get to work. All right, thumbs up, people. Everybody see propane? It's coming on your screen magically. No, it's not magically. And propane, this is the condensed form. I'm going to do this. It's probably one of the rarest times I'll ever do this. Because it takes so much extra time. This is the expanded form, which nobody ever uses. You write it like this. Notice this carbon here has 1, 2, 3 carbon hydrogens, and we put the hydrogens here and the subscript 3. That tells you this carbon right here has 3 hydrogens. Now, if we look here, this one has 2, and this last one has 3. That's much easier. Now, it's time for me to teach you one of the most important things about organic chemistry. Carbon is what's called tetravalent. And there are always 4 bonds to carbon. That seemed like 3D coming right at you. 4 bonds to carbon. 1, 2, 3, 4. There's always 4. Oops, gotta get that finger fixed. There's always 4 bonds to carbon. By the way, I'm ambidextrous, so I can do it with both hands at the same time. Remember, there always is 4 bonds to carbon. So when there isn't 4 bonds, we fill them with hydrogens. So there are always 4 bonds to carbon. And if we were to use this molecule, this is called butane. How many of you have ever seen the little plastic lighters with a liquid inside? By the way, thank God, many decades ago, I gave up smoking. I was a chain smoker, addicted very badly. Luckily, I gave it up. I could tell you how many cigarettes I needed to go from O'Hare Airport to any major airport and city in the world. I still remember Detroit was a 2 cigarette. LAX was about 10 cigarettes. Schiphol, Amsterdam Airport was a pack and a half. Manchester, same thing. But this is butane. Now, how do we know how many hydrogens to put in butane? Notice there's one bond to carbon here, from this carbon to this carbon, but there's always 4 bonds to carbon. And therefore, now we got to use some high-level math. 4 minus 1, 3. So that means there's 3 hydrogens on there. Now let's look at this carbon. How many bonds are there to that carbon? 1, 2. But there's always 4 bonds to carbon. High-level math again. 4 minus 2, and times up. Hopefully all got 2. And therefore, there's 2 hydrogens. And this carbon has this one here, and this, it also has 2 bonds, but should always have 4 bonds. Therefore, 4 minus 2 is 2. And that one, I'm gonna let you try the last one because Dr. White shares the fun. How many hydrogens would be on that carbon? There's 1 bond to carbon already. Time's up. And thank you. I saw one of you ask, give me the right thing. 1 bond, 4. So 4 minus 1 is 3. So let me write it. Now you don't have to put the line here, but when I don't put the line there and I have more carbons, it tends to droop to the bottom of the screen, or in the classroom to the bottom of the whiteboard. So I put lines in, you can do with or without. And this is how you write butane. Remember, there's always 4 bonds to carbon. And by the way, butane, next time you see one of those lighters, you know the liquid in there is a alkane saturated hydrocarbon. Now, what happens we have this molecule? Now, I should warn you, organic chemists are lazy. If there's an easy way for us to do something and be lazy, we do that. So you've been forewarned. Remember, there's 4, oh, I gotta get this finger fixed. 4 bonds to carbon. Yes, 4 bonds to carbon. I'll be reminding you that students, if they looked at any of the tests, especially the final, and counted how many bonds to carbon, they would have seen, oh, I've got a molecule with only 3 bonds to carbon. And that's wrong. One time I saw on a test, the student had 6 bonds to carbon. It took me a couple minutes to stop laughing, and it was wrong too. Remember, 4 bonds to carbon. Now, when you have a repeating unit, like here we have CH2, CH2, CH2 bond together. How many are there? 1, 2, 3, 4. And a way to rewrite this molecule would be like this: CH3, then parentheses, CH2. How many are repeating? 1, 2, 3, 4. So to write subscript, you put a 4, then this at the end is CH3. And this is a way you can write longer molecules quickly and easier. Remember, organic chemists are lazy. Now, I won't be using this until we get into fats and oils. We'll get the molecules longer. And even though it takes me a little longer, I'll use this way, condensed, because I'll do that in the lectures and on the test, because it's easier for students. And that makes it easier. Now, there's one other way that I haven't had on the slide, but we'll do it for rings. It's called the line method. And the line method is every bend in the line is a carbon, every end in the line is a carbon, and you don't put it. Stay away from this. I know other instructors use this. Students have trouble with it. For rings, we'll use the line method, but for alkanes or acyclic compounds, this has 1, 2, 3, 4, 5 carbons. Another way of writing it, which I will. These are the same molecule. This one I'll stay away from because students get confused by it, even though I know how to use it. But I'm trying to help you learn, not confuse you. I'll let other teachers do that. Hopefully they don't. All right, so let's try. Ooh, I'm going to have you have some fun. Oops. I should warn you, in my class, there's a 20-second or 15-second rule. Since all my examples I'm doing on the fly, give me about 10, 15 seconds before you start writing down what I write down. All right, for that molecule, it's time for you to have some fun. Draw in the hydrogens. Ready, set, go. And for those of you turning on your webcams, thank you. And for those of you who don't, thank you for showing up too, but turning your webcams makes Dr. White happy. And remember, you're all new at this, so it may seem hard, but in a week or so, you'll say, how was that hard? All right. Give me a thumbs up emoji if you're done. See, if I were in a classroom, I'd look around, I could tell when everybody's done. It looks like everybody's done. So let's put in the hydrogens. This carbon has 1 bond. There's always 4 bonds to carbon. If you know an example where this isn't true, let me know, and it'll be rich beyond my wildest dreams. That goes beyond having my own Lamborghini and Ferrari, my own island, my own fleet of fighter jets to play with. Beyond that, it doesn't exist. So 4 minus 1 is 3. This carbon has 2 bonds. 4 minus 2, because there's always 4 bonds to carbon, would be 2. Same thing with this one. Same thing here. This one here also has 2 bonds. And there's always 4 bonds to carbon. And now the last one has 1 bond, 4 minus 1. See how hard the math is in my class? Let's try one more, but I'll do this one first. All right, let me do this one, then I'll let you have some fun doing one. Let's put in the hydrogens here. This carbon here has 1 bond. Therefore, it always has 4 bonds. Therefore, 4 minus 1 is 3. This carbon right here, same thing, 4 bonds to carbon, but it has 1 bond, so it should be a 3. Same thing with this one. 1 bond, but it should have 4 bonds, so it's 3. Now let's look at the center carbon right here. How many bonds does it have? 1, 2, 3, but wait, there should be 4 bonds to it, so there's only 1 hydrogen. And that's how you do it. And here's one for you to have fun with. Put in all the hydrogens. You're learning organic chemistry and see it's not that hard. And when you're done, give me a thumbs up emoji or give me a thumbs up if you have your webcam on. If we're in class, one of the things I usually say, when you're done, look up and smile. I have a whole class of smiling people sometimes. And if you finish early, please be patient. I try and give everybody time to finish. And give me a thumbs up if you're done. I think everybody's giving me that look, like almost everybody. All right, everybody done? Let's do it. This first carbon has one bond to it. There's always 4 bonds to carbon, 4 bonds to carbon. Therefore, 4 minus 1 is 3. Same thing with this one. 1 bond. Therefore, I'm going to put 3 hydrogens. Same thing here. 1 bond. And this carbon, 1 bond to it. There should always be 4 bonds to carbon. So I'll put 3. Now let's look at this carbon right here. There's 1, 2, 3 bonds to carbon, but there should be 4 bonds. So 4 minus 3, high level math, would be 1. Let's look at this carbon. There's 1, 2, 3, 4 bonds to it. 4 minus 4 is 0, no hydrogen. Let's look at this carbon right here. There are 2 bonds. There should be always 4 bonds to carbon. 4 minus 2, 2. And find the last one. There's 1 bond, but there should be 4 bonds to carbon. 4 bonds. And that means 4 minus 1, 3. And that's how you do that. If I look at the clock, oh no. Time flies when you're having fun with chemistry, organic chemistry with Dr. White. Time for a 5-minute break. I'll see you at 5 minutes at 2:50. I go stretch again. Y'all back to work. By the way, Dr. White has his toys. This is actually when I was in high school, I was into unusual whistles. This is from a taxi cab whistle that they used in the hotels. I don't know if they still use. And once in a while, I got this a while back, I'll use this one. I love that one. I told you I'm a wild and crazy guy. All right, let's get back to organic chemistry. Remember, there are 4 bonds to carbon. 4, yes, 4, 1, 2, 3, 4 bonds to carbon. Always. That will be your friend on steps 1, 2, 3, 4, and the final 4 bonds to carbon. All right, now we have what's called cyclic organic molecules, or the cycloalkanes. And these are represented by polygons. I'll never ask you how is cycloalkanes represented. It's by polygons. Poly means many, gon-sided. And the rule is each bend of a line is a carbon atom. And I won't do this, but each end of the line is a carbon atom, and each intersection is a carbon atom. But the important thing is hydrogen atoms are not shown on a ring using the line method. Let me show you, and I'll never ask you what's the rule for drawing it, but I'll expect you to know how to do that. All right. This is one of the rare times, so put it down in your diary. Dr. White's doing the expanded way, or the condensed way. Now, you'll learn later on, this is called cyclohexane. But anyways, this is a 6-membered ring. This is the last time you'll ever see me drawing it this way. It's drawn this way. Now, some days, how many of you have heard people say, you know, I'm having a good hair day or bad hair day? Well, sometimes Dr. White has a good ring drawing day and a bad ring drawing day. I have software that does this too for my test and nose. And let's do one more on the test. Ooh, that's a good one. And if you notice, each bend of the line, 1, 2, 3, 4, 5, 6. This is really this. They're the same. I just redraw it a little nicer over there. And this is how we draw a ring. 6 carbons is a hexagon, cyclohexane, and 5 carbons is a pentagon, which when I draw it, I think of the little greenhouses in Monopoly. By the way, when you played with your sisters and brothers, did you all cheat? Whoever went to the bathroom, the other person stole from the bank. We did. And you call that a square, organic chemists call that a ring. How many carbons in this right here? Well, you count the bends. 1, 2, 3, 4. Now, this you'd call a triangle. No, organic chemists call that a ring. Your turn. Think about how many carbons are in that ring. This one right here. Time's up. Every bend of the line is carbon. 1, 2, 3. Now, each one of these carbons has hydrogens. Let's look at carbon number 2. How many hydrogens would be on that carbon if we showed them? Well, there's 1 bond here and 2 bonds. And what do you know? There's 4 bonds to carbon. 4 minus 2 would be On this carbon, even though we don't show it, there are 2 hydrogens. So these are the main rings: 3 carbons, 4 carbons, 5 carbons, and 6 carbons. There are more, but in my experience as an industrial organic chemist in the real world, you don't run into 7, 8, 9. They're very rare or larger. But these, especially 5 and 6, and somewhat 4, are common. By the way, how many of you have heard of the molecule or compound or drug penicillin? I think most of you have. Penicillin has a 4-membered ring in it. How many of you have heard of cortisone? Cortisone has 3 6-membered rings and a 5-membered ring. So these are in your daily life already. And we'll learn more about them as the semester goes on, but this is how you draw them. You can draw them this way, but it's a waste of time. Are yours going to look as good as mine? No, I've been doing this a few more weeks than you have. A few more weeks, but you'll get the hang of it. And that's how you draw a ring. Now, switches off for here. What's the term I'll use? Isomers. Those are compounds with the same molecular formula, but different structural formulas. Example of an isomer: a pair of isomers. I'll never ask you to test an isomer, but I'll use the terminology. These 2 compounds are isomers of each other. They have the same molecular formula, C4. Notice 5 plus 5 is 10, H10, both of these, but they have different structures. They look different. And those are isomers. Quick Dr. White story. A number of years ago, I was watching TV in my family room, my Laser Boy. I've had Laser Boy recliners since '78. Oops, I shouldn't have said that. Now you'll think I'm an old guy. But anyways, I am. But I was watching cable TV. A commercial came on, and it was for a brand of cosmetics. And guess what the name of the company was? Isomers. I started laughing big time, almost fell off my Laser Boy. And every once in a while, I still see them on TV selling their cosmetics isomers. I should say cosmetics, nail polish, and perfume are very sophisticated organic chemistry. We'll talk more about that later in the semester. Yep, organic chemistry is everywhere. All right, now, about 1900, there had been a massive increase in the knowledge of organic chemistry on our planet. And a lot of great things were happening in the late 1800s, early 1900s. And the different governments of the world realized we've got to have a way of naming compounds, chemical compounds. And most of those were organic. By the way, organic's the best, but I'm biased. And switches off for the slide. A treaty was signed. It was delayed by World War I, right around 1919, 1920, give or take a year. And the United States was one of those countries that signed that treaty. And that treaty came up with a new group it established called Iupac, International Union Pure Applied Chemistry. Sounds cool, Iupac. And their task was to develop a system for naming all chemicals. And most of those were organic. And to this day, the job they did, and they're still working on the Iupac, it's called rules, and then this is a tremendous important aspect of chemistry, especially organic chemistry. Why is it important to know names? Well, how do I communicate with another organic chemist? Also, another very important way is in legal documents, contracts, and also patents. So names are important. Let's do something real quick. Everybody see Google? Back in '95, a friend of mine called me from California. I was one of the few people in the company I worked with that had a computer with internet. So you got to go to this web URL site. There's this thing called Google. I said, what the heck is a Google? And I found out it's been the best search engine ever. If you put in Iupac, you can go to International Union Pure Applied Chemistry. And here's their website. And their main mission in life and their headquarters in Geneva, Switzerland, is to be the arbiter and create new rules when needed of the names of all chemicals. Now, before the internet, about every 10 years or maybe even longer, Iupac would put out a series of books. They'd have a color like the gold book, certain year, another one was the green, where it'd have all its rules. And usually those books put together for about 4,000 pages. Now, do I know all the Iupac rules? No. Do I know the ones in the areas I work with? Like the back of my hand, I know it pretty well. And I'll be teaching you Iupac rules, and we'll do it step by step, and you'll learn them. This is important. One of the important aspects of organic chemistry in my class is how do you name something by the Iupac rules. And also here's the Iupac name, how do you draw it? And I'll be teaching you that. Now, the naming of compounds has a fancy name called nomenclature. Nomenclature is just a fancy name for the name of something. So when I say the Iupac nomenclature for alkanes, that's how you name them. Now, when you have a straight chain of carbons, the alkanes, simple alkanes, or as also known as unbranched, their names 1 through 10. Now, if you had the book, here's the table, but let's go, by the way, can't know these structures and the names, and I'll teach you how to memorize them right now. Everybody see on your screen the alkanes Iupac names? In the lecture folder of D2L, there's a file called Alkanes, Iupac names, and number of carbons. And here's the chart. 1 carbon alkane is called methane. 2 is ethane. Oh, 3, it's your old friend propane. 4 is butane. 5 is pentane. 6 is heptane. 6 is hexane, 7 heptane, 8 octane, 9 nonane, decane is 10. Dr. White's going to be subtle again. If you don't know this chart, you've just fallen 50 points on test number 1. On test number 2 and 3, you've just lost 40 points. On test 4, less. On the final, you just lost about 20, 30, about 30% of the points on the final if you don't know these. So how do you memorize this? You have to do, if you want to learn this and you want to get a good grade, take methane and write down the word methane. Why is this? Oh no, hold on. Let's try this. There we go. Methane, 1 carbon, and say it. Then do it again. Methane, 1 carbon, and do it another 3 more times. Methane, 1 carbon. Now you know now how to draw methane. Methane has 1 carbon. How many bonds to carbon? 4. So that's how you draw it. So this also helps you learn how to draw it. So for each of these, and I get started on it tonight, and because this is the summer and we go a lot quicker, learn the alkanes. And methane, 5 carbons, pentane, octane, 8 carbons. Oh, wait a second. 8 carbons, octane. How many of you have ever been in a gas station and you see that octane number? Well, that's because when they first were selling gasoline back in 1905, thereabouts, the best gasoline had the highest amount of isomers, you know what that means, of octane. And that gave it the smoothest running engine. Now gasoline is much different, much more sophisticated, but the octane number still plays a role. And octane, 8 carbons. And you need to learn this, memorize this table. Time for a public service announcement from Dr. White. Now, one company I worked with, Axo, it was then called Axo Chemie, and it changed its name to Axo Nobel. And the division I worked for 2 years ago got sold out as Nurion. We made chemicals that were used by the petroleum industry. People make gasoline. And because of that, my position in the company as an R&D manager, and I was one of the few PhD R&D people that sales and marketing people took out to clients because I knew how to talk to them. I got to go to a lot of the major petroleum producers like Shell, BP, back then it was called Standard, and Mobil, and others. And they all knew each other, and they all had rankings of who was the best gas. And I'll share that with you. The best gas is Shell. It has been for decades. Mobil is almost as good. Marathon, I forgot who they get it from, is quite good too. And the worst gas is BP, Standard. For decades, it's been the worst. I will not, unless it's emergency, go into BP station. That's my personal opinion. But if you go on Google and you search about 3 or 4 years ago in the Gary, Indiana area, and a part of Illinois right near across the border, BP put out some of the worst gasoline that, listen to this, destroyed the car engines of over 3,000 cars because the gasoline was so poorly made. And yeah, I don't go there. Now, when you go into a gas station, you know, there are different octane numbers. The highest price also has the best additive package. There are different chemicals that are put in there to help your car engine run better and parts of it stay cleaner. And the highest has the most expensive, and then the lowest one has the least. Now, having worked with these people, I found out something, and over the years, I know it's worked for me. Most of the time, I use the lowest priced gas. I have an SUV Explorer. I've had a number of Explorers. I guess if I had a Ferrari or Lamborghini, I'd probably not buy that, but I don't, at least not this week. one of these days maybe, but not this week. But about 4 or 5 times a year, I let my gas go down to about a quarter tank. Normally, I don't let it go down less than a half. That's my personal thing. But anyways, quarter tank, then I'll fill it with the highest premium Shell or Mobil. And that puts in the better additive package. And that helps keep the engine running. I've had cars which last a long time because I do that. That's just my opinion, but it's worked for me. And a little friendly advice from Dr. White. All right, so if you've learned this chart, if I were to ask on a test, what's the Iupac name for the following? Let's take a look. Oh, come on. Everybody see 3 points each? Thank you. All right, so if you were to see this on a test, what do? Well, first of all, okay, use a high level count carbons. 1, 2, 3, 4, 5, 6, 7, 8. It's got 8 carbons. It's a straight chain. There's no branching. I'll teach you possibly today, if not tomorrow, what's branching. And you have learned the following table. 8 carbons, octane. And therefore, the answer would be octane. And you'd write or print that out so I could read it, and you get your 3 points. What would be the Iupac name for the following? I'll never ask on tests, what does Iupac mean? That means the official name. Oh, 3 carbons, you know what that is. It's your old friend, propane. Oh, let's do one more. Notice each carbon has 4 bonds to it. Now, I'm going to let you try this one first. I ask a lot of rhetorical questions, it's a bad habit of mine, but first figure out how many carbons in that molecule. I see somebody already gave me the right answer, and the answer is 4. And you can also put it on chat if you want to, or not at all. And hint, hint, big hint, you've learned this chart. 4 carbons is butane. Isn't this hard? So that's what you get. Now, there are 2 types of nomenclature question. Remember, nomenclature is the fancy name for the naming a compound. One is give the Iupac name for, and the other one when I do a test, I like small part problems as opposed to big point problems. And sometimes I'll also draw the condensed structure for pentane. Now, I'll help you out. Pentane has 5 carbons. So why don't you try drawing a molecule with 5 carbons all across in a straight line? Remember, there are 4 bonds to carbon. See how cruel I am? I make you work in my class. Remember, pentane has 5 carbons, and there's 4 bonds to carbon always. So when you're done, give me a thumbs up. I think everybody's done. If not, somebody scream at me. 5 carbons. 1, 2, 3, 4, 5. This one, there's 1 bond to it. 4 minus 1 is 3. This one has 2 bonds. 4 minus 2 is 2. Same thing here. Same thing here. This last carbon has 1 bond to it. 4 minus 1 is 3. Now, one thing I should point out, my software, I finally gave up fighting with it over the years, likes to, on this end carbon on the left, this is called right justified. Sometimes it will do this. That's the only carbon that can be left justified too. So this and this are the same, and I usually try and always right justify it, but for some reason, even when I put it as it should be all right, it still does this. And by the way, I use ChemDraw, which is the best out there. All right, let me have you try one. Why don't you draw the structure of propane? Hint, hint, hint. 3 carbons. And when you're done, give me a thumbs up. I'm going to go to the other people too. Those of you out, your web camera on, don't forget, we have emojis which you can use to do a thumbs up when you're done. Or I can also, which I don't always do, let's try this. I can do polling. And that's the way I can see most of you are done. And you are. All right, let's do it. Propane. You have learned this table. Propane. How many carbons? 3. And therefore, I have 3 carbons. Each one has 4 bonds to it. This one has 1. 4 minus 1, 3. This one has 2. 4 minus 2, 2. This one has 1. 4 minus 1, 3. And that's how you do propane. And those are the 2 types of what's called nomenclature. Remember, naming of organic compounds that I will have on test. Now, good part of when we start out will be learning nomenclature, because this gives a strong foundation for you to build on. And therefore, test number 1 of all the tests this semester will have the most nomenclature. Historically, in every semester, I rewrite my test. Usually about 45, 50 points out of 100 are nomenclature. So it behooves you, ooh, fancy word. It's important that you learn that table of the alkanes 1 through 10. Start writing them down 5 times and say them. That works. For some reason, it works a lot better than flashcards. A lot better, but whatever works for you, use it. All right, now, the general name for acyclic saturated hydrocarbons, the alkanes, has the ANE ending. Alkanes without branches. By the way, these rules that are from page 44 and 45 that I've modified in your book, if you bought the book, you don't have to. I just saved you about $100 or more. So thank you, Dr. White. You're welcome. I'll never ask on a test what are the rules, but I will expect you to know how to do them. So everybody see number 2 on your screen? Alkanes without branches are named according to the number of carbon atoms in table 2.1 for the file I had just on there. Now, next one, alkanes with branches. And I'll explain what a branch is in a second. The root name is that of the longest continuous chain of carbon atoms. What does that mean? Well, let's find out. Let's look at this molecule. And if I were to ask, give the Iupac name of that, I'll wait. By the way, tonight at midnight, I'll be giving speed note-taking lessons. No, I won't. All right. Now, if we were looking at this and say alkane, and we'd say, oh, straight chain. No, there's something hanging off the straight chain. And this is called a branch alkane. Just like branches of a tree. And no, I'm not going to draw a tree. By the way, Dr. White will never go to art school. Never. My mother was a good amateur artist. None of that rubbed off on me at all. You'll find out later in the semester what I mean. But anyways, this is called a branched hydrocarbon. And the way you name it is you find the longest chain of carbons. Now, you notice I have a chain around my neck and it's straight, but I can bend it all different ways. And how many of you have ever played with a bicycle chain that you can go all different ways? Well, a chain of organic molecular carbons are carbons bonded together like links of a chain. And the first thing you have to do is find what is the longest chain. And let me show you how to do that. Now, if we look at here, oh, one thing I forgot to mention on a serious note. If anybody of you are colorblind, let me know in private. When I worked in industry at 2 different companies, I had colorblind chemists working for me. And for certain tests where they could, one was red, green, I forgot what the other was, we had to have someone help them out in certain tests because they're colorblind. I like to use colors on my slides, but if that's a problem, let me know in private. All right, we take and look at this. If I go across, this is carbon 1, is attached to 2, to 3, to 4, to 5, to 6, to 7. So that's 1, 2, 3, 4, 5, 6, 7. Remember this, I write my 7. That's one chain. Now another chain would be this carbon bonded to that carbon. This is linked together to this one. And then we come down here. That would be 4. There's a third chain. I start here, 1, 2, these are linked together, 3, 4, this one is 5, and this is now 6. It goes like that. So there are 3 different chains. One is 7, one is 4, one is 6. Now, the Iupac rules is you name this, the base name is the largest straight chain. And that, I hope you have the choice, 4, 6, or 7. What's the largest number? And I hope you all pick 7. And come on. Here's our longest chain. And what's 7 carbons? If you look at the table, 7 carbons is heptane. By the way, names, Iupac names go up into the thousands. In real life, you don't need more than 10. And that's why I'm only teaching you 10. So heptane, everything in the red box is spoken for. Are we done? No, we've got something left over. This is called a substituent. Hopefully I spelled it right. If I ever spelled something wrong, let me know. I was always first one down. It also, when it's this carbon hydrogen atoms, has another name, alkyl group, which I'll be using. And what do we call CH3 attached to the longest chain? Well, there's a series of names for different alkyl groups. Does everybody see alkyl groups on your screen? Thank you. There's a file in the lecture folder of D2L, key alkyl groups. Now, there are many of them, but for most part, in everyday life, these are the key ones you have to know. When it's 1 carbon, CH3, attached to something, this long line means it's bonded to another carbon, like in a chain or ring. That's called a methyl group. 2 carbons are ethyl group. 3 carbons, we have 2 choices. Notice here, to the N carbon, that's called N-propyl. And the N is small case. One of the things I have a bad habit, other names I sometimes capitalize in lower cap, different things, but it should be a lower cap. If you do that, I won't take off points. Now, there's another propyl when you have 1, 2, 3 carbons to the center carbon of 3. That's called isopropyl. Anybody ever hear of isopropyl alcohol? I wonder where it got its name. I'll teach you that later when we get into alcohol. Now, for 4 carbons, there are 3. I'm only going to teach you 2 because the third one I have never used in my whole professional life, and only once at a lab at the other school have I seen that compound. 4 carbons, 1, 2, 3, 4, attached to the N carbon of 4 is N-butyl. 4 carbons, 3 carbons, attached to a center carbon, attached to something else, is called tert-butyl, but organic chemists are lazy and we usually call it T-butyl. After this week, I'm going to call it T-butyl because I'm a lazy organic chemist. Now, I should tell you, Dr. White loves T-butyl groups. I like isopropyl groups. They've been good to me, and I've been good to them. The others are very good too, but I really, really like T-butyl and isopropyl groups. And later in the semester, I'll explain why. The T-butyl group, it has something to do with potato chips. What? Yes, potato chips. Something I shouldn't have, but I do like. So if we go back to the very top, CH3 group, alkyl group, which is a substituent. It's called methyl. So heptane, we have our 7 carbons, the longest continuous chain. Then the substituent, in this case, only one, is methyl. Now, are we done? No. How many of you ever mailed cards or letters to someone? And if you put their name on a, say, a letter or postcard, and then their street address, not the number, street address, city, state, and zip code, what are the odds that will get mailed successfully to that person? Well, especially with our post office, the way it's been running lately, 0. So what do we do? Now, I've done this. Group attached to the main chain are called substituents. I'll never ask on test what's a substituent, and saturated substituents contain one only carbon or hydrogens are called alkyl groups. I'll never ask on the test what's an alkyl group. And here's one way of determining it. It's easier to memorize the chart I gave you. Now, the main chain is numbered in such a way that the first substituent encountered along the chain is given the lowest possible number. Each substituent is located by its name and a number to carbon atom, which is attached to. I'll talk about the next part later on today or tomorrow. Oh, one thing I should say, if you feel overwhelmed, take a deep breath, let it out, take a deep breath, let it out, relax. At first, even I had, what the heck is going on? Then a week or two, remember, it's more accelerated. They'll say, that wasn't that hard, but when it's new, it's challenging. Let me rewrite this. By the way, starting tomorrow, it will be your solemn responsibility in my class that when I write a structure on there, make sure they all have 4 bonds to carbon. Like if I didn't put the 2 here, let me know, because I'm going to be writing them at light speed. I'll be writing them at warp drive. For those of you know science fiction, that means as quick as I can. And now let's look, our longest chain was this. And here's the carbon the methyl group is on. Now, if I start from this side, 1, 2, it's on carbon 3. If I start from the other side, 1, 2, 3, 4, 5, it's on carbon 5. Now, when you're numbering an alkane, acyclic compound, a compound that's not in a ring, you can only start numbering from the end. I'll say that again. Common mistake students make. They start numbering from the first alkyl group. Wrong. You can only start numbering from either end. Now you have to use your high-level math skills, which is a smaller number, 3 or 5. Time's up if we all pick 3. So that tells you this methyl group is on carbon 3. And I will now put a 3 there. And the name of this whole molecule is 3-methylheptane. How do we do that? Found the longest chain. Remember how we counted the different chains? The longest one was 7. What's left over are alkyl groups. 1 carbon, CH3, is the methyl. So the root name is heptane. Next, 1 carbon, CH3, is methyl. What carbon is it on? You determine that by what carbon counting from the ends, which number is lower? And the answer is 3. All right, let's try the following. All I'm going to ask you to do is, for the molecule I just wrote on the screen, hopefully you all see it, what is the longest chain? That's all I'm asking. What's the longest chain? And I'll give everybody time to find out. See all these neat skills you can impress your friends, neighbors, and loved ones with, or your colleagues wherever you're working. And there are 3 possible chains. Remember, if you're having difficulty at first, this is challenging. But once you get the hang of it, practice makes perfect. All right, I think everybody's done. Let's take a look. Anybody need more time? Always feel free to privately send me a chat if you don't want to say it out loud. All right, we go 1, 2, 3, 4, 5. This carbon's bond to that, to that, to that is linked to that. That's one chain. This carbon 1 to this carbon 2, this one 3, 4, 5. Oh, the same. There's one more chain. And on a test, you have to show these numbers? No. But I am for you. 1, 2, 3. So 2 of them are 5, the other is 3. What's the largest number? And hopefully I'll pick 5. And if you notice, you learned the table with the alkanes, 5 is pentane. Now, as soon as I say pentane, and I could do the other one too, and you get the same answer. That's the beauty of Iupac rules. One molecule only has one name. One name, you can only draw one molecule if you do it right. So I have pentane. Am I done? No, look what's left over here. CH3, oh, it's your soon-to-be good friend, the methyl group. So this is an alkyl group right here. It's on the longest chain of 5 carbons. So we put that in front of the name, methyl. By the way, in typing, keyboarding nowadays, there's no space there, but as long as it's on the same page near when you write your test, that's okay with me. And what carbon is it on? Well, if we do in black, it's on carbon 2. We start from this end, 1, 2, 3, 4. And the alkyl groups get the lowest number, which is smaller, 2 or 4. Time's up. Hopefully I'll pick 2. And therefore, this is 2-methyl pentane. Oh my goodness. As I look at the clock, we're done for today. I hope you all enjoyed today's session with me, Dr. White. Remember tonight and also Wednesday night from 6 to 7:15, I have office hours. Come on by and say hello. If you need any help, I'm available. And with that, I'll see you tomorrow at 1 p.m. And with that, oh, quick thing. My background, oh, by the way, nice looking dog. My sister's a dog person. I'll tell you that story another day. But anyways, all my grandparents are from Russia. And if you came from Russia and Germany and you're Jewish, which I am, you speak Yiddish. And when the COVID-19 started getting bad, when I was little, one of the things my grandmother, Grandma Greenman, who was a great lady, I was lucky to know her, one of the finest women, the first people I've ever met in my life, she'd always say to me, and also my sisters and my parents, "Gehen gesund." When you say goodbye to someone, "Gehen gesund" is Yiddish for be healthy or go with health, which in our environment today is an important thing. So I'll always log off, "Gehen gesund," be healthy. I'll see you tomorrow. I'm done. I'll stick around for a couple minutes if anybody has questions. If not, you can run away now.